So I did have a backup application in case anything goes wrong. Class started? Yeah. I did have a backup application which like works as expected. So in case anything goes wrong, I just pull that up. So I couldn't really find the actual reason. That was not really the actual reason. That was something else, which I think I'm just overlooking on something. I'm not really seeing that. But I will post tonight what was the actual problem. But the history that you would expect to see is basically like this. So if you see, this is like another application that I developed to build a test pipeline. And within that, I actually had a development basically a merge, which failed as planned. And basically, what I was hoping to see on the other application is basically to see this, that for the test, within that, I did have 9 tests that one of them actually failed. So I can basically see the reason that application that was failed. Yes, please. Yeah, sure. So yeah, so I'm actually able to refer to the part which failed, which is of course like 8 is not equal to 9. And that was the reason of the failure. And that happened actually at the time of the pull request. It means before merging that. So I cloned from that application so I can basically continue my development here. I will not really spend a lot of time, again, more on this. I'm going to jump on the other concept, but then the second day we will spend a little bit more time to just get it a little more mature and also bring in the machine learning pipelines, basically. Thank you. So if I again type code, bringing that. So this is basically that support application that the application that I was hoping to, in case anything goes wrong. Again, it takes a little bit of time to pick up the right branch. Absolutely. Okay. All right. So I just want to just practice that. Yeah. Just let me go to the GUI to make it quick to show you how that actually works. This is the GitHub repo which keeps the backup application. Go to test repo. And yeah, so what I want to do, I want to just, make a very small change. I go to the test branch. I open up a file. I just open up a file. I make a change on the GUI. I just wanted to save some time. So just add a new test and then hit commit. I want to basically commit it to the test branch, right? So now test branch has something which the master branch doesn't. Now I'm going to go back to the master branch. So you see this one, which is it shows that there is a branch which is ahead of the master branch. So I can now hit the pull request. And in the pull request, hopefully this time it works fine. Nothing bad happens. Okay, so new build is kicked off. The test branch. and all of the steps are passed. So there is one error. I think the test is still incorrect. So if you see that that is failed, so let me close this pull request. I quickly go to the tests for this branch. Yes, please.
You might increase the font that
Sure.
Okay, thank you.
No problem. Anytime. Yeah, that's the reason why it is failing. So within the test, I intentionally added a failure. So just change this to 3 and hit commit. Now there are now 2 changes that needs to be committed. So again, going back to the roots. So I need to zoom back, pull request, new pull request, and basically test to the master, hit create. So now okay. So there's a new pipeline is kicked off behind the scene. So that was successful this time, as we were expecting to see successful. And yeah, so what I would be able to see here is within the, so it means everything has passed, so all of the checks are passed, so I can basically hit merge pull request. So it means that I can trust now the tests behind the scene, so it needs to those be solid enough that by seeing this failure or success, basically I can just hit, I want this to be merged. Now I can have another pipeline only for the merge. If you remember going back to the continuous integration, if I click continuous integration, they will kick off a new pipeline when the actual merge happens. Means the master code base actually gets updated, then the new pipeline will be kicked off. Yes, please.
As soon as you now can say confirm or accept the merge, that pipeline is going.
Exactly, we'll get excited. Exactly, the pipeline which has that continuous integration checked in, basically. Yeah. And I would highly recommend, when you go back home, if you have time during the weekend, play around with that. Just create a couple of branches and just play around with the concept, because next week going to be a little bit more complicated in terms of the modeling, etc. will be added to that. Awesome. There is just one thing, just nothing really important. That is the batch, which is a very useful batch. Basically, if you go to many of the GitHub repos, there's a batch which shows whether this job was successful or not. So how you can get that? So you can go through the pipeline that you created in the Edit tab, and also if you web search for batch for Azure DevOps, you will find a way to do that. You can basically, in the Options tab, there is a link with a markup link. It means anything which needs markup, like Jupyter or README file on your GitHub, can basically read that, and then you will be able to basically replace it here. So if you just paste it inside this readme.file, as I already did, you will be able to see whether that was a successful pipeline behind the scene, was a failure behind the scene or not. Awesome. We don't have a lot of time for the next section of the workshop, But we will spend, again, we need to spend some time next week to basically complete, go over the experimentation and reproducibility. So please go to this address. Absolutely.
So this is the CI tool from Microsoft Azure, which we were just looking at. So if you would compare it, say, with, say, Circle CI or Jenkins or Travis, which one, how would it fall?
Yeah. So Azure Devops is basically a hosted DevOps tool where we can, for instance, run Jenkins pipelines inside Azure Devops. So that's like again, like a cloud environment where we can have Linux or Mac or Windows in it. Exactly like an open environment where we can have multiple types of pipelines. One of the pipelines is for Azure DevOps, which is like a native pipeline, but you can, of course, bring in Jenkins pipelines as part of those templates. So that doesn't really be any difference between that. There are other cloud providers also have the other CI/CD pipelines. I would say when you are within those, it's simpler to use the native, basically, DevOps pipeline, because it will get some kind of native connectors to some resources. Like here in Azure DevOps, we can connect it to, for instance, Azure ML natively as part of the templates, where I don't think you can find it on GCP. You have to like provide your own YAML file if you want to talk to Azure ML, for instance. These type of things are different here. Yes, please.
Don't you want like a YAML file or something like committed to version control rather than like having Azure like run this pipeline that can be changed independently of the code?
So when
like
YAML, you mean the YAML like the pipeline
like,
definition?
Don't I want my pipeline also committed to version control?
You can actually do that.
Yeah.
So this GUI is basically not a YAML way, but if you do the YAML way, at the end it will create a pipeline, Azure-pipeline.yaml file that will be pushed to your basic source repository. And the good point for that is basically if you move it somewhere else, you have the pipeline definition instructed there, which means, yeah, it becomes more shippable somehow. I pick GUI because it's simpler to go for step by step, but at the end, if you also go to the actual pipeline, which has the GUI, you can get the YAML equivalence of that, where, for instance, these are my steps. If I click on View YAML, I will be able to see this. And then I can create another pipeline, which gives me a complete empty YAML. I basically paste it here, and I can customize and change and modify the YAML file with a new pipeline. Yeah. At this time, there is no way to convert between UI and YAML within the same pipeline. You have to create a new pipeline if you want to be GUI-based or file-based, basically.
If you wanted to create another
CI, you go build a new pipeline again?
Exactly, yeah. Yeah, the question is if you want to create a new pipeline, you basically go to the pipelines and then hit new pipeline here. It will be a new pipeline basically for a new task. Yeah. Awesome. Yeah.
So let's say the advantage if you would use Jenkins is that, or you have your Jenkins pipeline, and then there's like a certain part that is specific for the cloud. And so if you want to just move, say, the cloud provider or whatever, you're just more flexible.
So even within Jenkins, you can write, for instance, CLI commands. Like, for instance, CLI are command interface commands, like gcloud, for instance, for Google, or AZ for Azure. I'm not sure what is the equivalent in AWS, but these are like CLIs. So within Jenkins, you can run CLIs, which makes it basically cloud agnostic somehow. And again, Jenkins will be deployed and run on a virtual machine. So let's say if you run Jenkins on Azure, it will be executed on a VM on like Ubuntu or Mac or Windows or whatever you want, and they will be basically like run the same kind of commands and scripts on those machines, basically. Yeah. All right, so if you go to this link, we have only 3 minutes. So yeah, it's good that you spend some time studying this, and then we will shouldn't be this one. Let me give me a second. So public. Absolutely, yeah. Is there anywhere that you can increase the volume?
This is for online. The online
Okay.
can hear you perfectly.
Perfect. Sure. No problem at all. Okay. Reproducible experiments. Public. So I'm pushing my code to this repo. Okay. Oh, yeah. Here we go. All right. Please go to this repository. And so what you need to do, you need to come to this repository, which will give you this address. I posted that within the class everyone. Within that, you need to just click on clone. You can download it somewhere, or you can get the link. That will be easier if you do this, if you clone it. So you just copy this link, go to a folder that you want to basically start your development, like here. Open up your shell or like terminal or command line, and then call git clone. Just type git clone, and then the URL which points to my repository, and then hit enter. So it actually creates the folder for you, so you don't have to do that, and then you will basically have the file here. So once you do that, you basically can now run Jupyter Notebook. Okay. Okay, so any of you couldn't install the Azure ML SDK on their local computer? Everyone installed that? Yeah? Okay. So do you remember anyone who installed within, I assume you installed within the Conda environment and everything, right? Conda, Azure ML Conda environment, right? So open a terminal again there. I open my local computer, and I would type conda activate Azure ML. So what it does, it will switch my conda environment to Azure ML. So it means that the packages which I install within the conda name, Azure ML, I can name it anything I want, are now accessible. So I can just basically have some packages installation which doesn't have any interference with other environments. So I can basically separate some, build some separations for the packages that are installed. This is like a Git concept, nothing related to Microsoft or anything else. So within Azure ML Conda environment, you will do Jupyter Notebook. So it opens up this folder, which contains the reproducible experiments. So let's have some setups here. So next week we won't have any like delay to start the session. Again, there are like some material here on the slides we can go through if you want to like recap on some of the Git commands and etc. And all right. So again, going back to the reproducible experimentations, An experiment has a couple of things which are unique for machine learning problems. One of the concepts is data. The data itself can change over time, can have different versions, which can result to different model. The code itself can change over time. We can have one time a hyperparameter tuning algorithm testing so many algorithms, the other time only picking a scikit-learn, just playing with some type of just having hyperparameters. And so it can be these two can build drastically different models. And at the end, there will be a model itself, which will be basically different every time we build it. So every time we are doing all of these iterations, we will have different data, different model, different code, different metrics to basically are part of this, which all of them will become integrated to build that actual unique model itself. And sometimes we do have the environment, which is like the compute environments, where again can be different. If your part of your experimentation is like training a deep learning model, you will probably use a GPU or TPU. Sometimes if it is not, you will just CPU is enough, so you will basically pick CPU, and that will always be different, right? So you want to keep all of these dependencies always in version, so then later on you can reproduce that over the time. So I'm gonna skip these and come to the Azure ML. So could everyone follow these instructions and follow my basically these steps? Go through the portal. Let me open on. Go to portal.azure.com. So what we want to do, we want to basically create a resource which is called Azure Machine Learning Workspace. So within Workspace, we will have all of these artifacts there, so we can basically manage our work there. So because I already logged in, I don't need to log in, but of course you need to log in if it is. I have created, again, I'm using a free credit to just make sure whatever I'm doing is following your experiments. We are done with the time, but we're gonna be faster. Hit plus here on top right, on top left. Search for machine learning. The first item is machine learning service workspace. Click on that. Click on create. And then provide the name, like test in class. I think this name is not really good, so test in workshop. All right, so for resource group, you need to pick something, just hit create, just select something, like again, workshop resource group. And resource group are logical containers. So if whatever resource you build, it will assign it to resource groups. Therefore, you can group them into multiple projects or multiple like business units and etc. And then you will pick a region. Just pick any region you want. I pick the US is 2. Hit create. So when you hit create, you will see something here opening up. Is now starting to deploy some resources. So while you're deploying the resource, I'm going to go back to the previous resource that I created for this course to show you that there's a couple of information you need to extract from it. So again, when you go home, when you go to the home, if you search here for the name that you provided to create your resource, you will be able to get it, like first example, for instance, or within your homepage, you will see that. When you go within that environment, you'll basically be able to see some information here. So you need to replace the information which I use within this notebook. If you go down a little bit within this notebook, you will see a subscription ID. You need to change it with the information you see here as subscription ID. The other information is basically the resource group. Again, you can get it from here. The resource group is basically provided here. Again, the name that you provided. And then the workspace name. So the workspace name is the resource that you just created, the ML workspace. You again provide that name here. And the name is actually provided here, the first example, for instance. And then the region that you created that. once you have created, then you will be able to run up to here without any problem. After this step, you will be asked to log into the Azure portal asynchronously and then synchronously, and then you will be able to get access to the Azure resource. And then from now on, this WS is pointing to this workspace in the cloud. If you have any problem, if you face any like errors in the running this code, like in terms of it has some problems in installation, the package, or anything else, you can basically again go to the notebooks .azure.com and then upload this notebook or Forknix my basically GitHub repo into your Azure notebooks. Within Azure Notebook, everything is pre-installed for you, so you don't have to install TensorFlow, Scikit-learn, or Azure ML. All of them are, the SDK and everything else are pre-installed, so you don't have to do that.
Is the Azure Notebook same as like Google Colab?
The same, yeah, the same concept, yeah. Yeah. Just as the final note, there's also another way to run your VMs. Again, if that, for any reason, you don't like that. This is a premium notebooks that you can create here within your workspace environment. You can basically launch a preview now, and then what it does, it creates a VM for you. So it creates a VM where on that you can run notebooks. So, but the difference is that you can pick the type of the compute, like you can pick a very expensive and very powerful compute, but that's not free. The notebooks are free on AzureNotebooks.com, but here you have to pay basically. But because again, it's free tier, you don't have to pay at all. Yeah, so make sure you go through these and have your workspace up and running for next week.